Kinetic molecular theory is the theory that's used to describe the way gases behave. You need to know the 4 points of it because there's typically a multiple choice question on the test related to it. And it says that gas particles are constantly moving. There are no attractions or repulsions between gas particles. And when they collide with each other, they collide like billiard balls on a pool table. There's a ton of space in between gas particles because the particles themselves are extremely small. And the speed at which they move is going to increase with increasing temperature. Now, there are a few other properties of gases that you're going to want to keep in mind, like gases have varying shape and volume, which we talked about previously when we discussed the states of matter. Gases expand uniformly, they compress uniformly, they have really low densities, and they mix uniformly with other gases in the same container. And thankfully they do, because if they didn't, you'd have to maybe run to one side of a room to breathe oxygen and then run back to where you were. In student exercise number 1 of the chapter handout, it says, why does warm air rise? So this is related to the fact that as gas particles increase in temperature, they move faster and they're actually spreading out further, which is going to decrease the density. So warm air has a lower density than cool air. Let's talk about pressure. Pressure equals force divided by area. It is a result of gas particles colliding with the surface of their container. So the more gas particles collide with the surface of the container, the higher the pressure. If I increase the moles of gas particles in a container, there would be more to hit the inside of the container, so my pressure would also increase. A couple terms you need to know is atmospheric pressure, which is a result of the air particles in the environment, and a barometer is used to determine the atmospheric pressure. It's a sealed container. It's typically made of glass. It has liquid mercury inside that rises and falls based upon the atmospheric pressure. Okay, on the second page of your chapter handout, I gave you some of the common units of pressure. In table 11.1, I listed Pascal, which is PA, atmosphere, which is ATM, millimeters of mercury, which is mmHg, torr, TORR, pounds per square inch, which is PSI, and inches of mercury, which is INHG. I also gave you some equivalents that I'm going to write down for you. 760 torr equals 1 ATM, which equals 101,325 pascals, which equals 760 millimeters of mercury. I also gave you a millimeter of mercury is equal to 1 torr, and an atmosphere is equal to 14.7 psi, and 1 atmosphere is equal to 29.92 inches of mercury. Okay, so these will be given to you on a test. You do not have to memorize these, but you need to be able to use them to do basic pressure unit conversions. So one thing that I need to explain is the fact that 760 torr is equal to 1 ATM, or it's equal to that many pascals, or it's equal to that many millimeters of mercury. You can also use 1 ATM equals this many pascals, or 1 ATM equals this many millimeters of mercury. Just depends upon which units you're trying to cancel. So if you look at student exercise number 2, I've got 125 psi in a bicycle tire. And I want to convert that to millimeters of mercury, but there is no direct conversion to millimeters of mercury. There is only a conversion from PSI to ATM, which I have to do first, and then ATM to millimeters of mercury, which I have to do second. So put 14.7 psi on the diagonal and 1 ATM on the top, like this. Okay? $125 divided by 14.7 is 8.503 ATM. And I'm not going to worry about sig figs until I'm done. Now you take 8.503 ATM and convert it to millimeters of mercury using this right here. Okay, so 1 ATM goes on the diagonal, 760 millimeters of mercury goes up on top. like this. So we multiply by 760. I'm going to want 3 sig figs in my answer. I got 6462.5, but since I want 3 sig figs, I'm going to round it down to 6460, which is like this. Okay? Okay, now I gave you one more example in the chapter handout for converting 173 inches of mercury into PSI, which is pounds per square inch. Again, there is no direct conversion between inches of mercury and PSI. You first have to convert inches of mercury to ATM and then ATM to PSI. So this is another two-step problem. So here's the first setup. 173 divided by 29.92 is going to be 5.782, and I'm not rounding off to sig figs yet. Then you can convert ATM to PSI in the second step. So 5.782 ATM, and 1 ATM is 14.7 PSI. So times 14.7, you're going to get 84.99. So since I want 3 sig figs, I'm going to make this 85.0 PSI. Okay? Okay, now you have a worksheet on pressure conversions. In your packet, it looks like this, okay? I'd prefer you did not use these useful equations. Use the equations that are in the chapter handout that I showed you, okay? So these that are at the top here, those are the ones that I want you to use for doing your pressure unit conversions. Now, there are a couple I didn't give you. I didn't give you the kPa and the centimeter, millimeter, centimeter, inch conversions, so you can use those. So the 1 ATM equals 101.3 kPa, and the 1 inch equals 2.54 centimeters, and the 1 centimeter equals 10 millimeters. You may need to use those, okay? And you're going to have to do your work on a separate sheet of lined paper, staple it to the worksheet, and turn it in.